Okay, guys, we're going to be studying similar shapes as well. Similar shapes and congruent shapes, those are two different concepts. What do you think similar shapes are? Yes.
Two shapes that are the same shape but different sizes.
So they could have the same shape but different sizes. Okay. Okay. Same shape but different sizes. Yeah.
So
Yes.
they could be like the same shape, different length, and then but the angles could be the same.
Yeah, which is maybe an extension of what she said. Like you said, same shape but different sizes, right? What could make the sizes different? The dimensions, maybe the length and the breadth. But you will notice something about similar shapes. And maybe let's write that one down. Any shapes that are similar should have corresponding angles equal to each other. So their angles are equal, but their other dimensions like their length and so on could be different. So similar shapes have corresponding angles equal. So the angles must be equal. That is number one. But when it comes to the sides, the sides won't necessarily be equal, but the sides will be in proportion. So their corresponding sides are in proportion. We will explain what this means in this lesson. Okay, so that is or those are the two conditions for shapes to be similar. Their angles should be equal, but their sides should be in proportion. All right. And so guys, tell me, if they give you two shapes and they ask you to prove that the shapes are similar, what two things should you check for? You need to check that angles are?
Corresponding.
No, just check that the angles are
Equal.
Equal, right? Are the angles equal? What else do you check? Yes. Check whether the sides are in proportion, right? I'll explain what proportion means now. First of all, the notation for similarity is this kind of thing there. Do not confuse it with the one for congruency, right? Congruency, the lines are horizontal, but for similarity, they're kind of like that. They don't have to be vertical, but they're facing up like that. So that is the notation. Right, so I want to explain what I mean by the two conditions that we've stated above. So guys, let's suppose that triangle ABC is similar to say triangle PQR. So we are given a triangle somewhere, ABC and PQR, and we are told these are similar. So if these two triangles are similar, then their corresponding angles must be equal. In other words, their angles must be equal. So which angles must be equal here? Do you see that? It's angle A and angle P. So angle A should be equal to angle P. If the two triangles are indeed similar. What else? Angle B should be equal to angle Q. Okay. And number 3, angle C should be equal to angle R. Okay. These are the angles. The angles are equal. Then when it comes to the sides are not equal. So the length AB is not the same as the length PQ. But the sides are in proportion, which means if we take side AB from this triangle ABC and we divide it by PQ. That is called the ratio. AB over PQ is called the ratio. So if you want, you can say corresponding sides are in the same ratio. That is exactly the same thing as proportion. Right. So AB divided by PQ must give you the same answer as BC divided by QR. I hope you see those drawings there. So we should get the same answer as BC over QR. We should also get the same answer as AC divided by PR. So AC over PR. So this is what we mean by sides are in proportion, which means the ratios that we get when we divide corresponding sides will be the same. All right. I think this will help you a lot. Drawing this will help you a lot. What animal is this now?
A frog.
That's a frog, right? Okay, so that is the face of a frog. So if this is ABC here, then that could be PQR there. So we are saying angle A is equal to angle P. And we are saying angle B is equal to angle Q. That will be enough. It follows, obviously, that the remaining angles will also be equal. So if these two triangles are similar, then we expect those angles to be equal. But we also expect, number one, the length AB divided by the length PQ to give us the same thing as BC divided by QR. From this one here, we can actually write three equations. This here is three equations. I've just written the one equation there. So one of them is AB over PQ is equal to BC over QR. The other one could be this one here is equal to that one there. So that's another equation. The third one could be this one here equal to that one there. So I can just write them down separately. So the other equation is BC over QR must be equal to AC over PR. So that's another one. Then the last one could be AB over PQ is equal to AC over PR. I'd like us to look at an example. We are given quadrilateral ABCD and quadrilateral EFGH, and we want to prove that ABCD is similar to EFGH. Right, so ABCD, that quadrilateral, you will notice is all four sides equal, 33 centimeters each. One angle there is 60 degrees and the opposite angle there is 60 degrees and so on. So you can almost tell that is a rhombus, right? That should be a rhombus. EFGH also, you will notice all the four sides are equal and the opposite angles are equal. So that should be a rhombus as well. But well, that has nothing to do with the question that we are answering. So let's prove that these two rhombuses are similar. And then maybe later on you can ask yourself, are all rhombuses similar? Okay, right. So we said to prove that shapes are similar, we need to show that all their corresponding angles are equal and their sides are proportional. So let's start with the angles in this case. And please start like this. I know that you will be referring to the first quadrilateral ABCD there. So in quadrilateral ABCD and in the other quadrilateral EFGH, we are getting our information from those. Can you name any equal angles? Clearly, angle A is equal to angle E, which we know is 60 degrees. And this is given. Right. So angle A is equal to angle E is equal to 60 degrees. That is given. Number 2, angle B is equal to angle F is equal to 120 degrees. Again, that is given. Then angle C is equal to angle G, which is 60 degrees. That is given. It will not always be given. In some questions, you will actually be calculating them and showing that they are equal. But in this case, fortunately, everything is just given like that. The fourth statement is that angle D is equal to angle G. Sorry, is that okay? Sorry, is equal to angle H, which is 120 degrees, and that is given. Then let's rush quickly to the sides. Now for the sides, we need to take corresponding sides. If you take AB and you divide it by EF, the answer is 33 over 45. You can simplify that, but we can leave it like that. So AB is equal to 33 over 45. If you simplify that, what is 33 over 45? You can divide by 3, I think. 11 over?
First time with calculator.
Okay, yes, you can give me whatever answer. What do you get? 1 comma? It can't be 1 comma. 11 over 15?
Yes.
Okay, right. So then let's move on to BC. In this case, there's no need for a reason. We know that AB over EF will give us 11 over 15. And BC,
Shouldn't we say like given or something?
no, you could say given. If you say AB is equal to 33, given. They did not give us here that the ratio is 11 over 15. We are calculating it using what is given, right? So don't worry for this part. We really don't have to say that. So BC over FG is also 33 over 45, right? Which is 11 over 15. Then the next thing is DC over HG is also 33 over 45, which is 11 over 15. And finally, AD over EH is also 33 over 45, which is 11 over 15. So what are we getting from this? We're getting to understand that the sides are in the same ratio because the ratios are equal in all cases. Now the ratios are equal, which means the sides are proportional, and the angles are equal. So the conclusion is, therefore, ABCD is similar to EFGH. To EFGH. Now the reason is corresponding angles are equal and corresponding sides sides are not equal. Corresponding sides are in proportion. Okay.